what kind of devices can we design. Currently, we do have workflows for transtibial models, transfemoral models, TLSOs, and either 3D printing for FDM or MJF, or SLS for that matter, as well as being able to carve a positive limb shape. So I will give just a very brief 2-minute video demonstration here of what the FlyShape software looks like. You can see on the top, we have this very step-by-step regimented approach where we start out with orientation. We can confirm measurements and make sure that what we took on our hand measurements on the limb actually match up. We can move around trim lines into specific places that we'd like to and save that trim line as a template as well, so that we have something to work off of from and it's not starting from scratch with many different or similar BK models. Here we have some region template zones where we're able to make these very targeted modifications for buildups or pushes. These can also be templated. Again, looking at making this powerful and simple and intuitive is really what we're going after. With also having all the different tools that you would otherwise want as a busy clinician looking to effectively operate a digital workflow in your clinic. We can also provide the global reductions by percentage. So we can see what the grayed out version of what the limb looked like before and then what the limb looked like afterwards, and otherwise just have bony anatomy regions untouched completely during that approach. I will pause on this part just for a second here. This is our fabrication step. So I have been brought on to the team to further develop really this section of the software where we are looking at base mode and non-base mode FDM printing specifically for test sockets, flexible inner sockets, and soon to be definitive sockets as well. So this approach here would be able to automatically design your device extremely quickly, whether you want to carve a limb shape or do base mode or non-base mode 3D printing. We can get into the nitty-gritty of what base mode design looks like maybe at another time. Feel free to reach out. But at the end of this design process, you'd be able to export these STL files directly to your fabrication method of choice. Here we have a nice alignment area where we're able to view exactly how this system would be aligned with any componentry that we have in our library so that you can preview what that would look like. A lot of different distal lens options as well for componentry that we're completely updating, and that's ongoing as well. Having some very simple and guided tools here. Again, you can go from a raw 3D scan to a finished device in less than 10 minutes. That's our goal. So currently we do have the option just to be able to export this STL file, but we're also working towards working with a few different 3D printers, FDM, to have that direct to G code as well. So with the Orton software suite here, you can take a 3D scan just from your phone in less than a minute. And in less than 10 minutes there, your modifications are done. And then in less than 2 to 3 hours, depending on if it's a below the knee or an above the knee prosthetic test socket, you have that ability to create those devices very quickly in base mode printing.